So we're going to talk about assignment 3, and I'm just going to kind of review it for you so that you can see what I was trying to get kind of out of this and where I was trying to go with the whole assignment. So I've got the PowerPoint on one side and trying to think of the word, the spreadsheet on the other side, so you can see both. So I can just kind of show you. Right, so first of all, we talked about dollar returns and we talked about percentage returns in class, so I'm not too worried about that. Percentage returns allow us to see the scale of the return. So did I get $1 from a dollar investment or $1 from $1,000 investment? Quite different. And it also addresses timing. You can put it on an annual basis. In this case, it's a monthly basis, so it's okay to address timing that way. So it's a monthly basis instead of an annual basis. So this is how much I'm losing or making in this particular month on each of these stocks. The total holding period return, I did not have you calculate. I used to do it in the old assignment, and maybe I'll start doing it again, but I wanted to make a couple of points about this. So total holding period return is over a period of T years. So it's not annualized. It doesn't have to be on an annual basis like it normally would be when we're looking at returns to compare them. This is over the whole time period during which I own the stock. Notice that I told you to get 7 years, but that's actually not quite the same as 7. Well, it is the same as 7 years of monthly returns. I'm saying that wrong. Because we didn't have the end of October yet, we actually wound up getting not quite 7 years of returns of prices. So that's okay. We're going to make sure that we adjust for the proper number of months. So let's just see the number of months here. I'm going to do a separate thing here. Number of months of return, and I'm going to use the count function to get that. I'm just going to count the number of returns so I can show you something about the holding period return. Okay, so they're 82 instead of 84. There are 84 months in a 7-year period. So that was my goof up when we got the original returns, but it's not a big deal. Okay, so total holding period return. I want to look at what I got for the stock if I had sold it in, this is August of 2016 instead of October, but that's okay. Divided by what I would have paid for it had I bought it in October of 2019, or sorry, 2009, and subtract 1. So I'll show you that formula again. If I do that, then I'm going to get a total holding period of 0.4783. So that's 47.83%. Let's put this in percent form. I'm going to use my format painter to put this in percent form so that you can see. Now, the thing that I wanted to point out about this is if I take this geometric average holding period return that I calculated using this funny Excel function, geomean function, and I multiply that by 82, which is the number of months of returns that I've got here, I get 39.18%. So it's not quite the same, because this would be closer, or a closer analogy would be, let's fix this. A closer analogy would be an arithmetic return, but it's still not an arithmetic return. I'll talk to you about that difference in a little bit here. Okay, so let me just hide a couple of these columns so that you can see everything. So that you can see everything. Okay, so the total holding period return is 0.4783 or 47.83%. The geometric average monthly return is 0.48%, and if I multiplied that by the number of months, I would have 39.19%. So let me show you how to use the total holding period return to get a geometric mean. So I'm going to geometric, and this is going to be calculated directly, not using Excel. So I'm going to take 1 plus the total holding period return to the power of, oops, this, sorry, my Surface tablet's a little bit weird sometimes on my keyboard. 1 plus the total holding period return to the power of 1 over the number of months in the period. And, oops, I gotta subtract 1. Okay, and let me put it in the same format as this number. And I could give it more decimal places, and you can do that if you want to prove it to yourself that those two numbers, this number, I'll show you that one, this number and this number are the same. So prove that to yourself. Next, also, when the periodic returns are given, you can do this 1 plus r1 times 1 plus r2 and so forth, subtract 1. That is exactly what this function is doing, that geometric mean function. So I had to add 1 to each of these returns, because if you look at the geomean function in Excel, and you go like this, I have to go over here and do it, and you type geomean, and you open that up, you'll see that it returns the geometric mean of an array or range of positive numeric data. Some of these numbers over here that I'm adding 1 to here, some of them are negative. So when I add 1, all of them are positive. So look up on in your statistics book or wherever you want what exactly a geometric mean is, and you'll see that this calculates the geometric mean literally from the perspective of geometry. And when we take geometric mean this way, we add up all the returns here, 1 plus all the returns here, and then if we take the nth root of that and subtract 1, we've got the geometric mean. So you can see how all of these things relate, and they're all pretty much the same. Oops, pretty much telling you the same thing, except for this one. That one's kind of like an arithmetic average, but not really. You can also see the difference between the arithmetic average and the geometric average, which I'm going to talk to you about right here. Okay, so here's an example. An investment that provides the following returns over the 4-year period. You've got the total holding period return, which I calculated on my spreadsheet, didn't have you calculate, and the average, the geometric average is you take all of those, you add them up, you add them all up, and you take the teeth root. So in this case, t is 4, get 9.5844%, and it's also equal to 1 plus the total holding return. Take the teeth root of that, subtract 1. Get the same number using either. The geometric average is not the same thing as the arithmetic average. So we probably talked about that a little bit in 3312, but maybe not. The arithmetic average of those is 10%, which of course is not equal to 9.58%, because the arithmetic average doesn't take into account compounding. And so for various reasons, there are various scenarios in which you're going to use the arithmetic average and various scenarios in which you would want to use the geometric average. Okay? So that's just a challenge to have you do that. Okay? Average returns, standard deviation of returns, historical returns, and we talked about these things in class. And these are just those distributions that I was showing you what we mean is mean and standard deviation.